Okay, hello Primer 6. Today we are going to start our second term. We will start with Unit 1, Force and Motion. This unit consists of two lessons. The first lesson is types of levers. Well, before we know the types of levers, we must know what are levers. Levers were invented from long ago by the man to do or perform the tasks more easily. For example, scissors are example of lever, the manual broom, the wheelbarrow, and the ice holder. These levers help us to perform or make the tasks more easily. The first people who invented the levers were from Greece. The scientist who described the levers, his name was Archimedes. Well, we now will describe the levers. The levers, look at these examples. They are rigid bar or solid bar. The bar may be curved or straight. See, here is curved, here is curved. So, the levers are rigid bar. The levers rotate or move around a fixed point. This fixed point is called fulcrum. This fixed point is called fulcrum. In the nutcracker, here is the fulcrum. In the scissor, here is the fulcrum. In the wheelbarrow, here is the fulcrum. So, to sum up, any lever consists of a rigid bar and it moves or rotates around the fixed point called fulcrum. Also, the levers are affected by two forces. First, the resistance or the weight or the object that we need to move, the force we need to move, and the effort, which is the force exerted or done by the person. So again, what are levers? Levers are rigid bar, rotate around a fixed point called fulcrum and affected by effort force and resistance force. The resistance force, we give it the letter R. The effort force, we give it the letter F. And the fulcrum, we give it the letter O. Again, what is fulcrum? It is a fixed point where the bar rotates around. The resistance, it is the force that resulted from the weight of the body that we need to move. And the effort force, it is my force or the force done or exerted by a person to equilibrate or to be equal to the resistance force. Well, I told you before that the levers are important because they help us to perform the tasks easily. But how? Some of levers help us to increase the force. For example, the bottle opener, it's easier for us to use it instead of using our hands to open it. The nutcracker, if we cut it with our hand or with our teeth, it will be so strong. So we use the nutcracker to cut it more easily. Even the crowbar, see the crowbar? We use the crowbar to make small efforts to produce great effort. So one of the importance of the levers is increasing force. Other importance is moving the force from one place to another, like the manual broom. The manual broom, we use it to move the dust from one place to another, and also it increases distance. See the man at the upper part of the broom, he is moving his hand the small distance, while the lower part of the manual broom moves larger distance. So we can say one of the importance of the levers is increasing distance and also moving from one place to another. Other importance is increasing the speed. We use a hockey bat to increase the speed of the ball. If we kick the ball or move the ball with our hands, its speed won't increase as we hit it with the hockey bat. So the hockey bat is used to increase speed. Other uses is accuracy in performance. We use the tweezers to pick up very small object. So accuracy in performance. One of the uses or one of the tasks of the lever is accuracy in performance. One more use is preventing our hand from the dangers. We can't move the ice we can't move or hold the ice a long period of time. Even the coal, we can't touch the coal. So we use a coal holder or the ice holder to avoid danger and protects our hand from being hurt. To sum up, the levers are important because they perform the tasks more easily as through increasing distance, increasing speed, increasing force, moving from one place to another, accuracy in performance, and avoiding dangers. Here is a give reason. The manual broom is considered as an increasing distance lever. Why the manual broom increases distance? Because when you move your hand a small distance at the upper part, the lower part moves a longer distance. That's why the manual broom is an increasing distance lever. Well, according to the position of the fulcrum, according to the position of the effort and resistance, we classify the levers, or we put the levers into three classes or into three types. First class lever, second class lever, and third class. How we classify them? Here are three levers. The seesaw, here is the fulcrum, while the boy will exert a force to push or the girl up. So the boy is the effort force and the girl is the resistance. So where is the position of the fulcrum? The fulcrum is between R and F. So here I'm having what is in between the fulcrum. While the nutcracker, my hand is the force, the nut is the resistance, and here is the fulcrum. So what is in between? What is in between? The resistance. So here is the resistance is between the effort and the fulcrum. While the tweezers or the coal holder or the ice holder, here is the fulcrum, the effort is in between, and here is the resistance. So the effort is between fulcrum and resistance. So we classify them according to the position of the fulcrum, the effort, and the resistance. If the fulcrum is in between, it is first class. If the resistance is in between, it is second class. If the effort is in between, it is third class. Well, in first class we are having what is in between. We are having the fulcrum between resistance and effort. Here is the hammer. Here is the hammer. Here is the hand. See? Here is your hand, which is the effort, and then here is the resistance, which is the needle or the pin, and here is the fulcrum. So the hammer is a first class. Also the nail clipper. Here is the nail clipper. Here is the effort, fulcrum, and the nail that you need to cut is the resistance. So the fulcrum is in between. Also the pincers and the pliers. The water paddle, here is the effort, the water, pushing the water is the resistance, and here is the fixed part, which is the fulcrum. The seesaw, here is the fulcrum. So the fulcrum is between the resistance and effort. Some other examples. Some other examples is the water pump. Here you put your hand, which is the effort. You pull the water up, which is the resistance, and here is the fulcrum. So the fulcrum is between the R and F. Even the common balance. The common balance here is the fixed point. You put the fruits or the vegetable here, and you put the weight here. So the fruits and the vegetables can be considered the resistance, and you put the standard masses to equilibrate the resistance. So the common balance is an example of the first class lever, and also the scissors. Here is the force, the fulcrum, and the resistance. Give reason. The water pump is a first class lever, or the paddle is a first class lever. The scissor is a first class lever. Why? Because the fulcrum is between the force and the resistance. By the way, primer 6. Look at the nail clipper or the pliers or even the scissor. The nail clipper, the pliers, the pincers, and the scissors, each one of these levers, each one of them consists of 2 levers. So they are considered 2 levers of first class lever. Well, the second class, I'm having what in between? I'm having the resistance force, the force that I'm working on it. Examples of the second class lever: the wheelbarrow. Here is the effort, the weight or the resistance, and here is the fulcrum. The stapler. You put your hand here, which is the effort. You press on the stapler. Here where you put the paper to stick them together, and here is the fulcrum in the fixed part. The nut cracker is an example of the second class lever. Here is the nut. The nut is the resistance which is in between the fulcrum, and here is your effort. Also, the bottle opener is a second class lever. See, here you put your hand. Here is the resistance where you need to open it, the cover of the bottle, and here is the fulcrum. Any give reason. For example, why the nutcracker is a second class? Because the resistance, which is R, is between F and O.